Okay everyone, welcome back to another video, and today I need 3 rockets for an upcoming video, upcoming project, and I really don't want to spend much money on them, so let's figure this out. Okay, so first things first, our design parameters. We need 3 rockets. They have to be low power. They're going to be identical in about every way except their fins, their cross section. One's going to be squared off, one's going to be rounded, and one's going to be in like aerofoil shape. We're going to use as many materials as I have as possible to minimize price.
The good news about model rocketry is that we have OpenRocket, which if you're unfamiliar with OpenRocket, it's really awesome. It's a free, easy to use software that really does everything as far as designing model rockets goes. So yeah, you can put out your components, seek them out, and then it has like the motors. So it'll actually give you the data, predicted data on like how high the rocket will go based off the details you gave it using the motor that you chose. It'll also, most importantly, show you the stability, right? A little bit of a simple gauge of the stability. It'll show you the center of pressure, center of gravity there, center of gravity, center of pressure. And so, yeah, here's the rocket. The test rocket one is what we have it called right now. We got 3 of them, and as you can see, they are functionally identical, and that is intentional, as we said. The only difference is the fin cross section, which, guess what? The good news is there is a setting for that in OpenRocket. It has everything. Now, one thing I will note, right? I'm planning on using 3D printed fin or a nose cone, a 3D printed nose cone. So I actually already have that made up in a CAD, and they actually have like they have a bunch of presets that have like the data on, like what body tube you might be using and so on and so forth. They don't have like even a material for a PLA 3D prints. Good news is you can just make a nose cone element and then just do a mass override. You just go into the slicer, of your 3D printer, see how much your 3D print, your nose cone will weigh, and just do a mass override there. Now, I will note what's really important to keep in mind when you do these simulations is that they're not going to be entirely accurate. Not everything's going to be considered. You actually see here that this is like very much an overstable rocket, which might make it prone to weathercocking, but it's fine. But like, there's just things you have to consider. The simulator is not 100% accurate, so it does give a approximate gauge of the altitude. We're going to be using the A83 motors. Now, again, make sure the general rule of thumb, not always the case if you're new to designing model rockets, but the general rule of thumb is that you want the center of gravity here to be 2 calibers ahead of the center of pressure. And as you with the motor in, test it. I get with all the motors that you might be planning on using. This is overstable because it's 5 calibers, but again, it should be fine. Plus, I didn't include every component on the inside. The parachute will most likely also kind of gravitate towards the back of the rocket, which will push the center of gravity forward. The reason the center of gravity is so far ahead is simply because PLA and 3D printed nose cones, they tend to weigh a lot. And so it does bring the center of gravity forward, which can be beneficial, can't hurt. But besides that, yeah, that's the general thing. Again, all 3 of these rockets look functionally the same, but they have slightly different results with the launch. For example, it's predicting that on the squared fins, it will go 58.6 meters. The rounded fins, it will go 70.8 meters. And with the airfoil fins, I spelled that wrong, it will go 72.4 meters. Again, might not be accurate. And again, as we design this rocket, as we build this rocket, there might be some changes that we make. So we might adjust that in the OpenRocket just to, make sure it all works. But yeah, keep all that in mind. But that is how you design a rocket.
Now, our next step will be the body tube and the nose cone. Now, the nose cone, we're just going to print out of PLA. We're going to just follow the design that we gave. And for the body tube, we are going to have to buy these. We're going to buy some Estes BT55 body tubes. And here they came. Let's crack these bad boys open. Wait a second. Wait for it. Boom. There you go. That was about like $7. Now, we're going to cut these down to size with that bandsaw right here. We're going to 3D print this nose cone. Let's watch it go. It took about an hour and like not much PLA at all. So very nice. And there we go. Now, important aerospace stuff, so we got to handle it with care. Of course, when taking it off the printer, don't want to drop it or anything. Be very gentle with it. And, well, okay, that's fine. Anyways, next up is our fins. We want 3 to be squared off on the cross section, 3 to be rounded, and 3 airfoil. We Ended up using basswood just because that's what I had lying around and wanted it smooth and in a square shape to match that design I had an open rocket. So first we're going to be marking this down. They're going to be fairly small. These rockets are pretty small. So just little tiny rectangles. Let's just sketch those out. And then we're going to take these and cut them out. Little grid pattern because we're making 9, of course. Make sure that's all good. Mark up our fins. And let's cut those fins out with the bandsaw. Now the tricky part is sanding. The squared ones obviously don't do anything. The rounded ones you just round off. That's pretty easy. Now the airfoil, it is a little bit tricky. You have to get like a nice curve down, as well as rounding it. So I mean, it takes a long time. Most of the time we're spending is going to be sanding these down into an airfoil. There's a reason you don't always do this because it just takes a lot of time. But I think I got them pretty well. I got them pretty good. I used this Sharpie to like line up the center, and that really helped a lot as like a frame of reference while doing this. And now the next thing we're going to do, really quick, we're going to be super gluing our hooks onto the nose cones. It's really not part of the fin step per se, but that was part of this clip during the build. Because the next thing I do, I use those just to hold up the body tubes, and then I glue on the fins. I'm going to just show you me gluing on one fin onto each rocket because you guys don't need to see that like 50 times. Next up, the parachute, and that's really easy to homemade. You just need a kitchen bag, like a trash bag, and dental floss for the shroud lines. So both things you can find. We're gonna cut that out as like a template, and as you can see, we're gonna just glue that to hold it on, and we're gonna trace out a outline and cut that out, and we're gonna have to do that 3 times. This was like the most tedious process, not the cutting out, but the entire parachute process. Just doing 3 of those, it gets kind of rough. I will say that much. Now, next up, we're going to be just adding on the launch lugs, which add a couple extra things that are really their own steps. So the launch lugs are just paper straws, the shock cords, as you can see, for spares from old Estes kits. Just attach those to the nose cone and then back into the body. Very simple. And after that, we'll go on to the parachute. Okay, so I got my box of dental floss, and I'm just using the mat that I have as a frame of reference, or cutting those out to 18 inches, which is double the diameter of the parachute. I'm not sure from which end to which end, I think. But regardless, we're just using some tape to hold those on, serve as like little hooks, clear tape. Next up is the motor mount. We're going to use an 18mm motor mount. We're just going to buy that. But they don't include enough rings, centering rings, so we have to salvage some from old parts. Luckily, I had just enough lying around. So it did work out. And yeah, assembling those, simple process. I've assembled like 1 million motor mounts by now. It never gets old. It's sarcasm. It just is what it is. I mean, it's not too bad. It's not too hard. A lot of glue. Hands get a little messy. But beyond that, it's fine. And our final part is finishing it up, making it look pretty. So let's take out the spray paint and paint it. I forgot to record us painting the first one white, but we have one silver, and then the other one will be navy blue. And I hand it off to present me.
Without further ado, guys, we have our 3 completed rockets. The TSP FTR1 stands for Fin Test Rocket 1, Fin Test Rocket 2, Fin Test Rocket 3, the block, the radius, and the arrow. If you do remember, these 3 are functionally identical, barring some perhaps, build mistakes. You never know. Slight, unplanned inconsistencies, but overall, these should be functionally identical. Besides the one detail of their fin cross-section shape. So take a look at the block here. It has squared fins. The radius has rounded fins. You can just barely see that. And the arrow has airfoil fins. So there you go. Now, very simple build. I mean, you guys saw the whole process, but just to give it a quick overview here. Boom, we got the nose cone 3D printed. This is just written on with Sharpie, painted spray paint. I always use American Accents or Painter's Touch American Accents to paint my rockets. This spray paint typically, in my experience, painting it's hard. I'm not gonna lie. Like some of these spray paints, they just do not go on well. But I've never really had trouble with American accents. Painter's touch, um, whatever it's called. But yeah, um, again, these in total, the three of these guys cost me about like 15 bucks to make, and that was simply to buy the body tubes and to buy the engine mounts. The rest of the stuff, I mean, it's just stuff I had lying around at home. Simple fins, they're made out of basswood. Grain goes this way, which is what you want. That way it's stronger. If the grain's going this way, then it might snap when it lands, but these guys probably aren't going to be going high enough where it's at risk of breaking basswood. Basswood, I will note, I think I already talked about it, but in case I didn't, sorry to repeat myself if I did. But what I like about basswood is it's a little bit hard. It's still fairly light. It's definitely not nearly as light as balsa, but it makes up for it by being a lot stronger. And it's also just naturally like much smoother in my opinion. It's just, I like basswood. It's not like as hard as plywood, not as heavy as plywood. It just kind of works for me. Um, but the only reason I actually used it on this rocket, I usually use those on like mid-power basswood on mid-power rockets. These are obviously very low power rockets. The reason I use these is just because this is what I had lying around. Again, saving money. Pop open this nose cone. Let's see what we got here. I just have a layer of clear tape just to make it a little bit tighter because it was like slightly small. My 3D printer's tolerances are a little bit off right now. Again, as you saw, trash bag to make the parachute, dental floss to make the shroud lines. Boom, very simple. This is like about a 10-inch, 9-inch diameter parachute. I mean, at rockets this small, like it's gonna be fine either way. You could use a streamer. You could even probably risk tumble recovery. Probably not with a nose cone this heavy. I'd be worried about this coming down like a lawn dart. So really anything to just not make it lawn dart is enough. And here you can just barely see these sampling holes up here. These are just cut there, holes made with an X-Acto knife. And this is just for the altimeter to sample air for its barometric pressure sensor. So it can actually give us a apogee reading. And the last thing here, focus, is I just have a paper straw as a, what's it called? A launch lug. Yeah, just long paper straw, kind of right around the center of gravity. Um, yeah, these ones are slightly bigger than the typical launch lug on a rocket of this size, but I just have a box of these paper straws, and I just use all of them, ton of them, um, for just model rocket launch lugs. I mean, it works well. I can use just a bigger launch rod that's really never hurt anyone, if you have it. So yeah, there you guys have it. 3 nice rockets. Come on, keep focus with me, guys. 3 nice rockets, very easy to make. And I mean, just goes to show you guys can make model rockets really easy. Here again is the open rocket sheets. That's about right, right? I did a good job. I mean, yeah, when I made these, I pretty much just winged it. You know, all I really need to know was fairly small rocket, try to use materials that I already have. And only difference is the fin shape. I mean, yeah, I chose the square fins just because it's easier to sand those down. And I mean, yeah, it came together really well, really easily, guys. Anyone can make a model rocket. I mean, especially like these. These are just nice, simple, low power rockets. So yeah, don't be afraid to try to make a model rocket of your own. This is not really a definitive guide. It wasn't trying to be a guide, but just an example. And it really doesn't really cost that much to make them either. And I mean, yeah, if you could like source your own tubes and stuff, it can be even cheaper. Um, and yeah, beyond that, guys, these rockets are going to be used in an experiment coming up on my channel. If you haven't figured it out by now, what we're going to be doing is launching these rockets a bunch, and we're going to be comparing the apogee on the different launches. You know, we'll be launching like these 3 on one day, and then we'll go wait a few weeks, launch them all again. Just keep doing that on the same motor, and we're just going to keep collecting the data on the max altitude, and we'll find out, you know, how much better is a rounded fin than a squared off fin, and how much better is a airfoil fin than a rounded fin. We'll see which one's most worth your time. This is gonna be a really cool experiment video. So be sure to stay tuned for that. Be sure to check that out. I'm really excited for that. I have a bunch more videos lined up. They're all really exciting. Also, be sure, just a quick shout out, be sure to check out our other channel. It's called Airbike NC, or actually KitFox NC and Airbike NC. It has all the videos on our Airbike, which is a home built ultralight, and and the upcoming KitFox, which is a home built experimental aircraft. all on that channel once we finish building. Right now, we're in the building process of that Kit Fox. But once we're done building it, we're gonna be flying it. So like, check that out. That stuff's super cool. And please like and subscribe. If you have any questions, any comments, then be sure to comment. Hope you enjoyed my video, and let's get some cool shots of these rockets.